Hello my dear students, welcome back to NEET World. So in this session we will be discussing the continuation to the last topic, that is haloalkanes and haloarenes right now. So complete haloalkanes part is over and then next we started discussing about haloarenes right now. So in the last class I also explained you about aromatic nucleophilic substitution reactions with a proper PYQs also. Okay, so that session will be highly helpful if you are preparing for NEET, JEE or EAPCET kind of exams. Okay, right, for all the exams the topic will be very useful. Yeah, you can watch it if you haven't watched it. Okay, and in this session we will be discussing few more the chemical reactions of this aryl halides, that is haloarenes. Okay, and before that I just want to brush up once again the preparation of the haloarenes from other compounds. For example, here the best example and more important example here is conversion of aniline to our haloarenes, that is preparation of chlorobenzene, bromobenzene using aniline. This is one of the very important reaction and there is a name for that reaction, you need to remember, because most frequently asked question in your JEE, NEET and EAPCET kind of exams. See, what they will be doing is halogenation of arenes. It means on benzene ring we required one chlorine or bromine or halogen, a fluorine, any of that. Okay, so this is what halogenation. So we are taking benzene and converting into chlorobenzene. Okay, this is what halogenation of benzene means. Okay, and here I will be going to explain about aromatic electrophilic substitution reaction so in the upcoming slides, but as of now you just look at here preparation of chlorobenzene or bromobenzene from aniline. Okay, just look at here. See, just take the aniline, that is benzene ring with NH2 group. Okay, phenyl ring with NH2. So you can say the most common name for this is aniline only. Okay, aniline. Okay, so this aniline treated with NaNO2 and HCl. So with what it is treated with? NaNO2 and HCl, it is 0 to 5 degrees Celsius. Now what happens? See, these two hydrogens and this oxygens removed as water, and what you are going to get? You are going to get a diazonium salt. What do we mean by diazonium salt? Between nitrogen there will be triple bond like this. Okay, see, this nitrogen having 4 bonds now, so it will be having a positive charge on it and chloride with a negative charge. So it is a salt now, it's a cationic part, anionic part right now. So you can say diazonium chloride. What is this? Diazonium chloride. So conversion of aniline to diazonium chloride is called a diazotization. What is a diazotization? Okay, remember this point. And next, so this diazonium chloride salt is there now, so it is unstable actually, it is unstable. So if you heat it, what I am saying, if you heat it, so N2 is a stable gas now, it tries to escape from this benzene, from the phenyl ring. Okay, so when it is escaping as a gas, as N2 gas, now what happens? It will be creating a positive charge on the phenyl ring, like benzene ring right now. So means what happens is this diazonium chloride will undergo some nucleophilic substitution reactions. How it will be undergoing nucleophilic substitution? See, it is going out now as N2, so the bond is also taken out by the nitrogen gas like this, minus N2 I am writing. So N2 gas is going out. Okay, so since here it is creating a positive charge, a nucleophile will enters there. Okay, so one nucleophile is going out and another nucleophile is entering in right now. So that is what substitution reaction taking place, I can say. Okay, right. So now we'll be explaining few more things. Just a minute, there is some power issue, I think so. Yeah. So what I told you, so aniline treated with NaNO2 under acidic medium like HCl under 0 to 5 degrees Celsius, so it will form diazonium chloride. So this diazonium chloride, upon treating with copper salts, with what? Copper chloride like CuCl, CuBr, gives chlorobenzene, bromobenzene. So this reaction is called Sandmeyer reaction. What is the name of that reaction? Sandmeyer reaction. Okay, instead of using copper chloride or copper bromide, if you use copper powder, what I am saying, if you use copper powder, okay, then the reaction is called Gutterman reaction. What is that reaction? Gutterman reaction. Okay, I will be explaining it once again, just listen here, just a minute, I will be uploading the same file here so that You can listen to this clearly. Yeah, so Sandemeyer reaction, Gutterman reaction, two of these reactions are very, very important. And one more reaction is a Ball-Siemens reaction. What is the third reaction I am saying? Ball-Siemens reaction. So what is the use of Ball-Siemens reaction? In Ball-Siemens reaction, we can able to prepare fluorides, so fluorobenzene I can say. Okay, so what is the reagent used there? So the reagent used here is HBF4. Okay, I will explain everything. Yeah, just look at here, we are using CuCl. It means what is the name of this reaction? It's a Sandemeyer reaction. See, our diazonium chloride treated with chlorine, copper chloride like CuCl. Now what it is giving? It is giving chlorobenzene. So N2 gas is going out. Now what is the mechanism involved here? Aromatic nucleophilic substitution reaction only, because N2 is going out. So substitution of one more nucleophile is taking the place of this N2 gas, so it's a substitution reaction. Okay, and if I use CuBr, you are going to get a bromobenzene. So what is the name of this reaction? Sandemeyer reaction. Sandemeyer reaction, you can remember. Okay, so instead of treating this with CuCl or CuBr, if I treat with potassium iodide Ki, we will get iodobenzene. Okay, we will get iodobenzene. If the same compound is treated with Cu copper powder and HCl like this, if we take, so here it will be generating a chlorobenzene. What is the name of this reaction? What is the name of this reaction? Gutterman reaction. Okay, what is the name of this reaction? Gutterman reaction. Okay, so now you can use Sandemeyer reaction, diazonium chloride with CuBr bromobenzene, CuCl chlorobenzene. Okay, if it is copper powder and HCl, then you can say it is a Gutterman reaction. So you will get a chlorobenzene here also, and you can prepare bromobenzene also here. Okay, so these are the two reactions to be remembered here. And one more reaction, what I told you, so Ball-Siemens reaction. What is the use of Ball-Siemens reaction? So you can convert aniline like benzene with NH2, aniline same treated with diazonium like NaNO2. What is the first step? You can say diazotization. So diazotization product is what we will be getting here, N2 plus Cl minus. Okay, diazonium chloride we got. So from here to here conversion, what is the species involved here? HBF4, HBF4 under heating condition. Now what happens? So this diazonium like N2 gas goes out from here and fluoride ion comes in. Okay, so you are getting fluorobenzene. So your fluorobenzene is a product formed. Okay, N2 gas is released, and then next from this HBF4, one fluorine is coming here, the next BF3 will be written like this. Okay, yeah. So what is the product from fluorobenzene? Okay, what is the reagent used? HBF4. Okay, and then next what is the name of this reaction? Ball-Siemens reaction. Okay, these are the points to be remembered here from the discussion. Okay, and the next one is I will be explaining you. Yeah, so the next one here is reactions of aryl halides or haloarenes, that is aromatic electrophilic substitution reactions, that is halogenation of rings. So here if I take simple benzene ring, what happens? Simple benzene ring upon treating with chlorine under FeCl3 like Lewis acid condition, under dark condition, heating condition. So what happens here? So it will be undergoing Friedel-Crafts reaction and gives you chlorobenzene. So this is how we will prepare our halobenzenes right now. So we got our chlorobenzene from simple benzene. Now you know this chlorobenzene will undergo aromatic electrophilic substitution reaction. How it will be? Yeah. So just see here what I am writing. Chlorine is there. See, electrophilic aromatic substitution reactions. First one, halogens are weakly ring deactivating and ortho-para directing group. Remember, whenever you are doing reactions with chlorobenzene with some electrophile. Now, where this electrophile goes? We know on benzene ring, if monosubstituted species is there, the adjacent groups with respect to that monosubstituted like group whatever present on a benzene ring are considered to be ortho positions, and the next third position is called this this third position and fifth position are these 3 comma 3, these both meta positions we can say. Okay, these are what? Meta position, and this fourth position is called para position right now. So out of these 3 positions, where this electrophile will be enters, where it will be substituted, that is a question you need to get. Okay, so look at here, like chlorine has lone pair electrons on it. Okay, yeah, so these lone pair electrons can participate in conjugation with the ring, and it will slightly activate the ring, and due to its more electronegative nature, the chlorine can withdraws electrons from it. So it can show minus I effect and plus M effect. Okay, so in case of halogens, remember, in case of halogens, the minus I effect is more dominating than minus M effect, plus M effect. Okay, yeah, so we will be having the chlorine is showing minus I effect, it means it will withdraws electrons towards it, that is called minus I effect through the sigma bond, and lone pairs can be donated into the ring, that is what, using the lone pair electrons, and the pi conjugation is there. So that is what we can say plus M effect. So these are the 2 effects present here, but whenever the halogens are present, here in halogens case, inductive effect is dominating than the mesomeric effect. In all other cases what we know, yeah, mesomeric effect is more dominating, but in case of halobenzenes like this we have means like inductive effect will be more dominating due to their electronegativities. Okay, this is one point. Okay, then considering both effects, the electrophile will be going to the ortho and para positions only. So you can say, considering both effect, you can say chlorine is a weakly ring like halogens are weakly ring deactivating groups. What I am saying, weakly ring deactivating groups, deactivating groups only. But this electrophile will be directed at ortho and para positions only. Remember this. It's a weak ring deactivating group, but electrophile will be goes to either ortho or para position depending upon its size and the other factors. Okay, so now you can write the predicted products something like this. So chlorine, here electrophile, and here also you can get like this, ortho para substituted product is getting here. And now relation to, comparison to benzene. So I am taking simple benzene and here halobenzene, like chlorobenzene I am taking. So which will be having more reaction towards aromatic electrophilic substitution reaction. Due to the presence of this chlorine, it is making benzene ring weakly deactivated right now. So that therefore aromatic electrophilic substitution takes place more effectively or more easily on benzene ring, simple benzene ring only. So the reactivity or rate of reaction, rate of electrophilic substitution reaction is more in simple benzene compared to the chlorobenzene. Okay, this is one of the very important point to be remembered, because yeah, we can expect a question directly on this kind of thing. Yeah, there is a JEE mains question previously asked on this. Yeah, you need to remember this point. Okay, so whatever we discussed till now, you need to remember that. Right. Yeah. So is it clear? Voice is clear or not? Everything is clear, whatever we are discussing? Yeah. The next thing is some reactions. I will explain you some reactions. Yeah. So if there is an enabler, please tell me. Yeah. So after this, look at this. There are two statements. There are two statements given here. Statement 1 says chlorobenzene on nitration gives 1-chloro 4-nitrobenzene as major product. Chlorobenzene undergoes nitration slowly, then benzene. Yeah, these are the two statements now. So from the previous discussion between chlorobenzene and simple benzene. So what I told you, which will undergo electrophilic substitution easily, the rate of substitution, electrophilic substitution is more in benzene right now. So here what they are saying, chlorobenzene undergoes nitration slowly then compared to benzene. Yes, this is correct only, no? Yeah, correct only. Now you need to justify this statement 1. Okay, so how do you justify that? See what they are saying, chlorobenzene. So you take chlorobenzene. Okay, so this chlorobenzene upon nitration, so nitration takes place with nitric acid plus sulfuric acid mixture. Okay, and from these we are going to get an electrophile, that is NO2 plus. What is the electrophile formed here? NO2 plus. We can call it as nitronium ion. Okay, so this electrophile will be directed to the ortho positions or at para positions as we discussed. Okay, so due to its bulky nature, so we can say the nitro group at ortho position having some steric repulsions and para position will be formed as major. So this is a major product. Okay, so we will get two types of products, one is para, other one is ortho substituted product like this, but which is major out of these two? The para one will be major. Okay, so now tell me here, see chlorobenzene and nitration gives 1 chloro 4 nitrobenzene. Yes, 1 chloro 4 nitrobenzene. Yes, this is perfectly correct as a major product. So statement 1, statement 2, both of them are correct as per our discussion, right? So you can say statement 1 is correct. See, statement 1, statement 1, statement 2, both of them are correct. So first option will be your perfect answer for the question. Is this clear? Is this clear or not? This is from EAPCET. Just check here, it is a EAPCET question. Okay, in the same way, we have few more questions to be discussed. I will discuss one by one. No worries about that. Yeah. So look at this question. What they are saying? What they are saying here? Benzene is treated with Cl2 in presence of FeCl3 under heating condition. Now what happens? Tell me. So whenever you have chlorine, it is treated with FeCl3. Now what happens? So it will generate an electrophile because FeCl3 is a Lewis acid and this chlorine will donate the lone pair electrons to this and it will form Cl, Fe, Cl3. So here positive charge, negative charge. So what happens from here? The chlorine will be taking, the middle chlorine will be taking the sigma bonded electrons, create electrophile chloride cation and FeCl4 will be formed. Cl4 minus will be formed. Okay, that's it. So this is our electrophile now. So what I told you on benzene ring, electrophiles will be directed to any of the position because all positions are same. So this is aromatic electrophilic substitution reaction. Yeah, this is a product formed. Okay, once after forming this, so our X formed here is chlorobenzene. So the chlorobenzene treated with Rx. What is this Rx? Alkyl halide in presence of sodium and dry ether condition. Now what happens? Tell me. A coupling reaction takes place. See, whenever you have alkyl like sodium metal, alkali metals in dry condition, what happens? So this alkyl halide and aryl halides will couple to give a product something like this. Yeah, so like this. So alkyl benzene is formed as your major product. So now what will be the name of this reaction? So the name of this reaction is, see, if only alkyl halides are involved, the coupling reaction is taking place between only alkyl halide, then you should call it as Woods reaction. What is that name of that reaction? Woods reaction. If only haloarenes like aryl halides are only involving, see, only aryl halides are involving in the coupling reactions. So if only these things are involving, you are going to get biphenyls like this right now. So these are called Fittig reaction. What is this reaction called? So this is called Fittig reaction. But in the given reaction, one is alkyl halide, the other one is aryl halide. So it's a combination of alkyl and aryl now. So you should call it as a Woods Fittig reaction. So what is the name of this reaction? Woods Fittig reaction. So where do we have that name? Yeah, so option C, Woods Fittig reaction will be a perfect answer for the question. Okay, Woods Fittig reaction is a perfect answer for this question. Okay, is this clear? Guys, is this clear or not? Yeah, then next here, look at this. which of the following is suitable to synthesize chlorobenzene? So how do we synthesize chlorobenzene, they are asking. See, if I add benzene plus HCl, will this reaction takes place? No. Why no? Because benzene aromatic species, this is highly stable right now. So it will not undergo addition reactions, because if it is undergoing addition reaction, it loses its aromaticity right now. So loses aromaticity and become an anaromatic compound. So it is a less stable compound than this substrate itself. Therefore, it will not involving addition reactions. So benzene will not undergo addition reactions. Okay, yeah, benzene can undergo substitution reactions, but not addition reactions. Why substitution? Yeah, so substitution means it will not lose its aromaticity, right? It will regain their aromaticity during the reaction. So it will only undergo substitution, not this addition reaction, remember. So second option is incorrect. Now what about the first option? They are saying phenol treated with NaNO2. Yeah, there is no use of treating this with, it will not gives you the product here, it will not gives you chlorobenzene. Now what about this? What about this? What about this reaction? No, this is also, see, aniline is given, NH2 is given and treated with HCl. Now tell me what happening here. See, NH2 is a base, like aniline is a base, aromatic amine right now. It's a weak base. So weak base with strong acid, it just forms a salt. Acid plus base now. So NH3 plus and chloride ion. Okay, so this is what anilinium chloride is formed as a salt. Okay, so it won't be forming us, giving us chlorobenzene. Now if you see this fourth option, so what they have did here, so benzene is treated with chlorine in presence of anhydrous FeCl3. So now what happens? So this chlorine and FeCl3 gives you chlorine cation right now. So chlorine cation will be attached here. That is what halonium ion we can say. So it will be giving you like chlorobenzene. Okay, so what will be your answer for this question? Fourth option will be perfect, right? So is this clear, guys? Those who are in the live session, please tell me. Right, the next here, if you see this aromatic nucleophilic substitution is over in the last class. If you haven't watched, please watch it. I clearly explained all the important factors that to be remembered from aromatic nucleophilic substitution in a very simple, in a crisp manner. You just watch it. Okay, yeah, this is the question from yesterday's discussion. Yeah, look at this and tell me what will be your answer. The compound that reacts the fastest with sodium methoxide ion. So sodium methoxide, yeah, sodium methoxide with these compounds, which compound will react faster? So what happening first of all? See, sodium methoxide means you can say sodium cation methoxide, OMe minus. Okay, so this is a OMe minus is a nucleophile now. So where it will be reacting, this is the reagent now. So this reagent should react with these four compounds, but out of these four, one will be more easily or more fastly reacting. Which one is that? See, wherever we have chlorine, there substitution takes place, nucleophilic substitution. But here already we have pi electrons right now. Between these nucleophile, this methoxide ion negative charge, electron density, and this pi electrons will repel each other now. So if the pi electron density is dragging towards electron withdrawing group, then the nucleophile attack will be easier. So where do we have that less electron density in the benzene ring? See, here we have two electron withdrawing groups now. So they will strongly drag the pi electrons of benzene ring towards themselves and create positive charge on this chlorine carbon, because this is para to chlorine, here also ortho with respect to chlorine right now. So nitro groups decreases electron density, electron withdrawing groups decreases electron density at ortho para positions. So more positive charge will be seen at here, okay, because two electron withdrawing groups are there. Yeah, here we have only one electron withdrawing group. So now what will be the most reactive here? First one, because it is more electron deficient. Then if I want to ask for order, then second one will be the next. Okay, but out of these two, which will be more reactive towards substitution? There is no electron withdrawing groups here. Yeah, at least here we have electron withdrawing group, but is that at meta position? No. Yeah, at least one electron withdrawing group is there. So you can say here 4 and least is 3. Okay, so this is how you need to write for nucleophilic, aromatic nucleophilic substitution reaction. Remember this. Okay, and the next one here is, yeah, tell me what will be the answer for this? Fittig reaction is, so what do we mean by Fittig reaction? It's a reaction between two aryl halides in presence of sodium and dry ether. Okay, so it is a reaction between, just now we discussed, if only two aryl halides are involved, then you should say the coupling reaction as Fittig reaction. Okay, if only two alkyl halides are involved for the coupling, then you can say it as a Woods reaction. If one aryl halide, one alkyl halide are involved, Woods Fittig reaction you should call. Okay, so here Fittig reaction means both of them are aryl halides only involving. So reaction between two aryl halides in presence of sodium dry ether is considered to be Fittig reaction. That's it. This is your answer for the question. Okay, right. The next one here is, aniline is treated with NaNO2 HCl under 0 to 5 degrees Celsius. Now what it will be giving? Diazotization taking place and gives you diazonium chloride, N2 plus Cl minus. So these treated with Cu2Cl, just now we discussed about Sandemeyer reaction, Gutterman reaction. Now, so this will be treated with a Cu2Cl2. Now tell me what happens, you are going to get a chlorobenzene, this remove N2 gas, place there chlorine. Okay, so the product formed here is X. Okay, what is the product formed here? X. So this is treated with methyl chloride. Now what happens? Remove this chlorine from here and attach between them, like couple them. So you will get methyl benzene. So what type of reaction it is? So what they are saying, X2Y, from here to here, what is the conversion called? It's a Woods Fittig reaction, that's it. Okay, how simple it is? Yeah. The next we have, look at these, what they are saying, water X and Y respectively in the following reaction. Okay, yeah, so we need to answer this question actually based on options. Yeah, if there is no option, see what I will be suggesting you is just follow me here. CH3 is there, bromine is there here. Okay, bromine under sunlight, UV light. Okay, now what happens, tell me? So this bromine will substitute, it means free radical substitution takes place. See, bromine in presence of sunlight, see, bromine is a symmetrical reagent now. So what happens when we pass this UV light? So it will breaks homolytically, two equal halves will be broken. So you are getting bromine radical. What are the species we are getting? Bromine radical. So that bromine free radical will abstract a proton from this benzylic position carbon. Okay, so after abstracting that hydrogen, what it will be forming? It will form a benzylic radical like CH2 dot Br. Okay, now out of these two bromines, yes, one is taking the proton and forming HBr. Okay, it will be forming HBr, and one more bromine radical is there now, so that will combines with this carbon radical and makes a bond like CH2 Br like this. Okay, so benzylic bromination takes place, like benzylic halogenation takes place whenever you have bromine in presence of sunlight or chlorine in presence of sunlight with alkyl benzenes. Okay, hope this is clear. Okay, the next one here, see, I told you that product, writing the product should be with writing the reaction should be based on the products given in the options. Okay, because this free radical substitution can take place one time like this, or see how many hydrogens are there? 3 are there now. So I can replace only one hydrogen, or I can replace two hydrogens, or I can replace like two hydrogens, CH, Br like these. Okay, or I can replace all three alpha like benzylic hydrogens. Okay, only benzylic hydrogens I am saying. Okay, like this also we can get. Okay, by considering mono substituted product, yeah, this is the mono substituted product. So this is the X I am considering. Now upon treating with hydroxide ion, what happens? This is a nucleophile. So the substitution of this bromine takes place by this OH minus. So you will get CH2OH and here Br, that's it. This is your benzylic alcohol is a product formed in the reaction, that's it. This is your Y. Okay, that's it. Right. Now if you look at this, tell me what will be the answer for this? What is your answer for this? Tell me. See, the following reaction method is not suitable for preparation of the corresponding haloarenes product due to high activity of halogen when X is. See, this will not be possible when we are, see, it is not possible, this method is not possible for preparation of corresponding haloarene product, okay, due to its high reactivity. See, reactivity of fluorines is greater, fluorination is greater than bromination, next then here chlorination in between, chlorination, bromination and iodination. So, this is the reactivity. So, it is not possible for fluorination. So, you can say first option is your answer, okay, that is it. Yeah. So, there is one more concept called benzene mechanism. What is this benzene mechanism? See, it involves two things. Okay, I will explain, just listen here. What happens here is, see what you are seeing, the place of chlorine we are seeing NH2. Okay, so how this is happening, just see here I am explaining. So here we have chlorine now. So adjacent to this chlorine we have hydrogens like this on all the carbons, right. So here soda amide, potassium like K plus NH2 minus is given now. So it acts as a strong base. What it will do? It acts as a strong base. Now when it is acting as a strong base, try to abstract a proton from this benzene ring. But which proton comes out? The one which is relatively more acidic. So due to the more electronegativity of this chlorine, adjacent hydrogens are relatively more acidic when compared with the other things right now. Okay, so which hydrogen to be deprotonated here? Yeah, either this one or this one. Let us remove this. What happens? We will be seeing a negative charge here and ammonia gas comes out right now. So this is what you are seeing. So this species once after forming, once after abstracting this proton, whatever the negative charge you are seeing, so actually this negative charge, whatever you are seeing, that negative charge will shift here, the chlorine comes out like this. So what is happening here, chlorine is going out and you are going to get a, this is benzene now. So I am writing one pi bond here. So what you can call it as benzene. What is this? Benzene. Benzene is the intermediate. Okay, right. So you have eliminated a chlorine from here right now. So chloride ion is eliminated from there. Okay, so elimination is over. Then next here, again you need to add NH2, like NH2 is the only species we have here. Okay, so this will be attacks any of these sites. So you can say, sir, there are two possible, I can add here or I can add here, no? Yeah, there are two possible ways to add. Let us say I am adding it this the same position as like chlorine. So that will be giving you chlorine like this, not chlorine, NH2. Okay, in the place of chlorine we got NH2. So wherever the substitute, like wherever the group, like eliminating group is like this group is eliminated now, to the same position we are adding this NH2. So you can say this as ipso product. What is that product? Ipso product. Okay, if it is coming to the adjacent carbon, see it is coming here now, so you can say it's a syn product. Okay, so I can write here, so this is syn product. Okay, you have two types of product, ipso and syn. Okay, now what are the things you are seeing? Elimination first, then followed by addition. First elimination, the next addition is taking place in benzene mechanism. Okay, remember these two steps. First step is elimination of chloride ion, the next addition of NH2 minus onto the benzene ring. That's it. Okay, yeah, there is one question from NEET exam. Just see here what will be the major product during this reaction. Okay, and how can you answer this? Tell me, how can you answer this question? Yeah, let me explain one simple question. You can try this. I will be giving you one simple explanation for this. Chlorine. Yeah, look at this, what I am doing here. I am adding a nitro group here. So Na plus H2 minus. Like this liquid ammonia with Na, they will mention other ways. Okay, same thing. Okay, sodamide. So now what happens, tell me. So this is a base abstract acidic proton. So which is more acidic proton, tell me here. Yeah, either this one or this one or this one. How can you say with respect to nitro group and this chlorine? See, this proton is in between two electron withdrawing groups, no? Yeah, this proton can be easily removed as a acidic proton. So that we will get chlorine negative charge here and NO2. Okay. So now what happens, this NO2, what I told you, that will be shifting like this and chloride ion goes out, like you got a benzene here. Right now this is a benzene product form. So intermediate form. So now again this NH2 will attack. So but NH2, where it will attack? Either this position or this position. How can you identify that? At the same position of chlorine or the adjacent carbon. So how do you identify the major product here? This is one of the important factor to be understood when you are doing this benzene mechanism questions. Okay. So now look at this, what I am writing here. Look at this, what I am writing. So the NH2 will be added to the same position as in the chlorine. Okay. If I add here chlorine, this pi bond will be shifting here when we add NH2 here. So negative charge will be here. Okay. NO2. And what about one more possibility? Yeah, I can add Cl here, negative charge at the other position. Negative charge. Now tell me which carbon anion is more stable. Out of these two, negative charge will be more stable in which case? Either this case or this case. Tell me. Yeah, see, if negative charge is more close to the nitro group, we will be having more minus I effect, because in benzene mechanism here you should not say anything about mesomeric effect. Here in this case that it won't work with mesomeric effect. It will be only given with respect to inductive effect, because it won't participate in conjugation here. Okay, right. Now tell me what I can say. Minus I effect will be more when that negative charge is more close to the electron withdrawing group. Since the electron withdrawing group and negative charge are more close here, yeah, the product formed here will be the major one. Okay, so what will be the product formed here? Cl, not Cl, this is what we are adding, NH2, no? So write NH2. Yeah, so what will be the major product here? NH2, NO2 and proton here. Okay, and this will be NH2, NO2. So tell me which is major? This one. Okay. So why? Because the negative charge close to the electron withdrawing group is more stable. So that's why this is the deciding factor. Okay. Now tell me, in the same position we have added NH2, right? So you can say this is ipso product. Ipso product is major. Ipso product is major, and syn product is minor. Okay. So based on this understanding, please tell me what will be the product in case of this. In case of this. Now what I told you, there is nothing like mesomeric effect here with respect to OCH3, you should take only inductive effect. Okay. So that too minus I effect, if more, the substitution takes place there easily. Okay. That's it. Addition takes place easily there. Okay. Right. The next, yeah, tell me about this one. What is the product? See, this is one of the very important reaction to be remembered. Okay, understood here. See, chlorine in presence of sunlight, whenever it is in this manner, I explained that whenever bromine presence of sunlight, UV light, I told you now. So what happens there? This whatever the benzylic hydrogens are there, at that position reaction takes place right now and gives you a final product something like this, CH2Cl. Okay, CH2Cl. So what is your product here? Yeah, third one will be your answer. Okay, but if I take chlorine Cl2 presence of AlCl3 or FeCl3 kind of things like anhydrous FeCl3, these things if we take, what happens, tell me? Here substitution, aromatic electrophilic substitution takes place at ortho and para with respect to this methyl group. So you will get CH3Cl here and CH3Cl here. So this is A, B. So here para product is major in aromatic substitution. So do you got the difference? Here chlorine in presence of anhydrous FeCl3 giving you this kind of product, okay, substitution product. But chlorine presence of sunlight gives free radical substitution. Both mechanisms are different. Here aromatic electrophilic substitution reaction, this is free radical substitution reaction. Aromatic ring, I mean on this carbon, benzylic carbon, free radical substitution is taking place. So look at the options here. See, there are traps for you. If this reaction is mentioned, what will be the major product? 1 will be major. See, if they are saying chlorine in presence of sunlight, it will be 3 will be the major product as per the options. Okay, is this clear or not? You got the difference between these two. This clarity should be maintained during the exam. Okay, if you are confused here, yeah, your complete answer will be wrong. Okay, so I hope the discussion is clear. Guys, if this is clear, click on the like button. Yeah, let me take some water. Yeah, so tell me, in which of the following compound longest CCl bond is there? Yeah, this is also interesting question and very basic. Based on GOC concept, you can answer this. See, the chlorine here having lone pairs now. These lone pairs sigma bond, pi bond. So they are in conjugative position, right? So it will be conjugation. So previously it is carbon chlorine looks like a single bond, but due to this conjugation it will gains a double bond character like this. Between this ring carbon and this chlorine will get a partial double bond character. So the same story here also, chlorine ring carbon are in conjugation and this is electron withdrawing group is there. So it will withdraw more effectively this electrons, so it will have more double bond character than the first option. Okay, more double bond character. Okay, so both of them have partial double bond characters and more for third option due to presence of release electron withdrawing group. Okay, now look at this. Yeah, here also you have conjugation like this. Here also we have conjugation. So due to that reason, yeah, it is also carbon between this chlorine. There will be double bond character in fourth option also. Okay, now what about second option? If you see, is there any conjugative positions? See, what do we mean by conjugation? Conjugative positions, lone pairs, sigma bond, pi bond, like alternate positions are there now. Yeah, so that is the scenario in first option, third option, fourth option. Okay, but not in second option. See, they are not in conjugation, and nothing like conjugation right now. So only lone pairs, sigma bond, no pi bond here. Okay, so this pi bond is an isolated one, not a conjugative one. So there is no pi like partial double bond character, only carbon chlorine single bond character is there in this option. So the longest, see, lower the bond order, greater is the bond length. Okay, only one bond is there, so larger will be the bond length. If more number of bonds, what happens? Atoms comes closer, so therefore bond order like bond length becomes small. Okay, so in this case bond length is becoming small as they are coming closer due to the conjugation, but these are only having sigma bond, so bond length will be more in second option. Hope the discussion is clear here right now. Is this clear, guys? Yeah, so again from the discussion only, what they are saying, which are the following reactions with the product obtained from them? Match the following reaction with the product obtained them. So tell me, Sandmeyer reaction, Finkelstein reaction, Schwartz reaction. Say Schwartz reaction is for preparation of alkyl fluorides, okay, and Finkelstein is for alkyl iodides, okay, and Sandmeyer reactions is for aryl bromides, this one, that's it. So A3, that's it. So A3, B1, B1, C2, B1, C2, C2, yeah. So option D is your answer for the question. Okay. So chloroform, what I told you about chloroform? So chloroform upon hydrolysis, upon treating with aqueous KOH, what happens? Wherever there are chlorines, replace them with OH groups. Yeah, replace it with OH groups. Okay, so you will get how many OH group, how many chlorines are there? 3. So replace all those 3 chlorines, you will get OH, OH, OH. So I told you on same carbon, if multiple OH groups are there, try to remove water molecules as many as possible. Okay, then you will get a formic acid like this. So treating with KOH, excess KOH is taken means it will form a formate ion. That's it. Okay, again one more reaction, chloroform with 6 Ags. Okay, just write it in this way: CH, Cl, 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 H. So remove this 6 chlorines using Ag as Ag 6 AgCl precipitates. So what you are going to get? A bond between this carbon and this carbon, like this acetylene is formed. 6 AgCl plus acetylene is formed. Okay, so that's it. And remember this chloropicrin. Okay, what is this chloropicrin? So chloroform plus HNO3. So CCl3NO2 is a product form. This is called chloropicrin, which is an insecticide. Okay, and the next here chloroform with acetone. Chloroform with what? Acetone. Okay, chloroform with acetone. So it will be forming this kind of chloriton is a product which is a hypnotic medicine. Okay, it's a hypnotic medicine. Okay, what is the name of that compound? Chloriton. Try to remember the reaction also, a product formed also, like CH3, CH3. Here one side OH, another side is CCl3. Okay, remember this. It is called chloriton, which is a hypnotic medicine. Okay, yes. So these are the things you need to remember from polyhalogen compounds also, right? So the remaining things, like we will be practicing few more questions from this topic, okay, in the short video format. So just go through the shorts also. I am discussing very important questions related to JEE, NEET and EAPCET in the short formats also, because maximum questions already covered in the class itself. Okay, and if you want anything extra from this chapter, you please try to write in the comment box. Okay, so in the upcoming session we will be going to start a new chapter, okay, like alcohols, phenols, ethers, or any other new chapter we will be coming up. Yes, the next chapter will be alcohols, phenols, ethers only. Okay, right. So if you are new to this channel, please click on the follow button. Thanks for watching. Thank you.